So a pair of dice is thrown. If the two numbers appearing are different, the probability that the sum is 6 or less. The total number of sample points but appearing different means it consisting of only 30, because total 36, but out of 36 both are equal appearing numbers are 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5, 6, 6. By excluding these 6 outputs, we are getting only 30 total number of sample points as per given condition. But in this one, the probability that the sum is 6 or less. If you take sum is equal to 6, then what are the possibilities here? 1, 5 and 2, 4, 3, 3, 4, 2 and 5, 1. And here we get sum is 6 if you appear anything in this one, and sum is equal to 5. So 1, 4, 2, 3, 3, 2, these 3, and sum is equal to 4. 1, 3, 3, 1, and 2, 2, and sum is equal to 6, 5, 4, 3. So 1, 2, 2, 1, and sum is equal to 2. So it is possible 1, 1. So to get the sum either 6 or 4, 5, 3, 2, we get these number of outputs. But in this one, the condition same number is not appearing, different numbers. So in this one, it is one of the case same number is appearing, and it is one of the case same number is appearing, and it is one of the case same number appearing. So out of 30, we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here one more 4, 1, 12. Totally we are getting probability of requirement x less than or equal to 6 is equal to 2 by 5. That is the probability of x less than or equal to 6 is equal to 12 by 30, 2 by 5. So if two coins are tossed, then the sample space is equal to HH, TT and TH, HT. This is sample space whenever two dice are thrown. But here the given condition, if it is given that at least one tail comes up, but how many samples are possible one tails come up? Only 3, that is TT, TH and HT. So it consisting of at least one tail, that is already given in the problem condition, one tail comes up. In this one, what is the probability of getting one head and one tail? And one head and one tail, we are having only 2 options. Therefore, required probability is 2 out of these 3 possibilities, that is 2 by 3. The residue of f of z is equal to sine of 1 by z. But residue is the coefficient of z power minus 1 in the Lorentz series of f of z. So therefore expand sin x expansion. Sin x expansion is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus etc. So in this one, the coefficient of z power minus 1, if we take in negative power, z power minus 1 minus z power minus 3 by 3 factorial plus z power minus 5 by 5 factorial minus etc. It is an expansion of given function f of z. So therefore residue is equal to the coefficient of z power minus 1, that is equivalent to 1. This question, x be a binomial random variable with the value of n is equal to 72 and the probability small p is equal to 1 by 3. And by using normal approximation to binomial distribution, our requirement probability between 22 less than or equal to x less than or equal to 28. So here first normal distribution. Normal distribution, the value of z is equal to x minus mu by sigma. So in this one requirements are mu and sigma, but mu and sigma not given. But binomial distribution conditions are given. By using them it can be evaluated mu value. But mu value is equal to np, that is binomial distribution mean. So where n is 72 and p is 1 by 3. So that is equivalent to 24. Mu value is 24. And sigma is root npq, that is standard deviation of binomial distribution. But in this one q is not given. But once p is 1 by 3, q is equal to 2 by 3 by using p plus q is equal to 1. So therefore under root of n is 72, p is 1 by 3 and it is 2 by 3. So therefore root of root 24, 16. So it is 4. So therefore standard deviation is sigma. So now here probability of 22 less than or equal to x less than or equal to 28. But 22 is equivalent to, here we have to find as a normal distribution condition. So therefore probability of 22 minus np, that is mu by sigma less than or equal to z less than or equal to 28 minus mu by sigma. Probability of 22 minus mu value 24 by 4 less than z less than or equal to 28 minus 24 by 4. Probability of 22 minus 24, it is minus 2 by 4 minus 0.5. It is a value of z less than or equal to, it is 1. So here as per normal distribution, our requirement is area or probability in between minus 0.5 to 1. So here as per this normal curve, we need to find the area under the normal curve between minus 0.2 1, 0.5 to 1. So by using normal distribution tables, probability of x0 less than or equal to x less than or equal to 1, this is by using normal distribution table. Normal distribution table value is 0.3413 from the distribution tables. And our requirement, one more summation here, probability of minus 0.5 less than or equal to x less than or equal to 0, that is equivalent to 0.1915. So here minus 0.5 to 0 plus 0 to 1, the total summation of these two areas is equivalent to area under the normal curve between minus 0.5 to 1. So by adding these two additions, approximately we get 0.53. It is approximate value. This is the probability between minus 0.5 to 1. It is equivalent to in normal distribution between 20 to 28. So integral around c cos pi z square by z minus 1 into z minus 2 dz, where c is the circle mod z is equal to 3. This can be evaluated by using residue theorem or by using integral formula. Just I am using a residue theorem. What is the residue theorem here? 2 pi I into sum of residues. Sum of residues which are inside of given c mod z is equal to 3. But here z is equal to 1 and z is equal to both are poles here. Z is equal to 1 and z is equal to are poles. Both are inside of the circle. Once if both are inside of the circle, then it is required to take both residues and summation. So first I am taking residue f of z is equal to cos pi z square. It is analytic function, and here the residue at z is equal to 1. Residue at z is equal to 1. Residue at z is equal to 1 implies limit z tends to 1 cos pi z square by z minus 1 into z minus 2 into z minus 1. So these two will be limit z tends to 1 cos pi z square by z minus 1 z minus 2 both will be cancelled, that is equivalent to here z tends to 1 cos pi is minus 1 and z tends to 1 minus 2 minus 1, the residue at z is equal to 1 is 1, and the second one residue at z is equal to 2, limit z tends to 2 z minus 2 into cos pi z square by z minus 1 into z minus 2. So these two will be cancelled. So z tends to 2. But once if you substitute z tends to 2, we are getting cos 4 pi. Cos even multiples of pi is always 1 by 2 minus 1 1. It is also equivalent to 1. So therefore as per this condition here integration is equal to integral cos pi z square by z minus 1 into z minus 2 dz is equal to 2 pi I into sum of residues, that is 1 plus 1, it is 4 pi I. So the value of integral 0 to pi e to the power of sin x dx by Simpson's rule by using two subintervals. But total intervals is given 0 to pi. And here by using two subintervals I am taking 0 to pi by 2 comma pi. So we get two subintervals. That is y naught is equal to f of x naught and y1 is equal to f of x1 and y2 is equal to f of x2. Here x naught is 0, x1 is pi by 2 and x2 is pi. So therefore f of x, but what is f of x here? E to the power of sin x. It is function of x in the integrand. So therefore y naught is equal to, it is f of e to the power of sin 0, that is e, and y1 e to the power of sin pi, sorry pi by 2, that is e to the power of sin pi by 2, that is e, sorry, it is e power 0. E power 0 is 1, and third one y2 e to the power of sin pi, again it is e power 0, it is 1. So y naught is 1, y1 is e and y2 is 1. Therefore your formula here, integration of 0 to pi e power sin x dx is equal to h by 3 y naught plus y2 plus 4y1. But in this one what is h here? H is equal to pi by 2. So therefore it is pi by 2 by 3. Y naught is 1, y2 is 1 plus 4 into y1, that is e. So is equal to pi by 6, and this is 2 plus 4e. Take 2 common, 2 pi by 6, 1 plus 2e. Pi by 3 into 1 plus 2e.